So I did astronomy research for many years, and then a couple of years ago switched into data science in the tech industry, where I still use a lot of the same skills. Actually, a lot of the stuff that I used in my research, I use for the TV tech company that I work for now.
Presumably making a lot more money than you ever did as an astronomer. And this
Sure.
is a really common transition. We've known a lot of astronomers who have started out in research and either after their PhDs or after some postdoctoral work have then switched into data science to follow money and job security and maybe other things. So we're going to talk to one of those today, an old friend of ours from the University of Texas at Austin, where he was a grad student doing his PhD in astrophysics and is now a data scientist with Indeed. So hi, Dr. Chris Lindner. Lindner.
Hello, nice to be here. I've known you guys for a while, and it's great to talk about data science. It's great to have colleagues that are in my new field as well as my old field. It's exciting.
All right, so let's start off with some of your astronomy research. So we've had people on the show talking about simulations, big computer simulations of astrophysical phenomena, specifically mostly talking about stellar birth. You and I worked together for a long time on stellar death and exploding stars and various ways stars died, and you were doing more of the simulation side. So could you go into just what you worked on? What was some of the fun, cool stuff that you did using that kind of stuff?
So we worked on different types of supernovae. There are basically a whole slew of different ways that stars can blow up. I was most interested in stars that were very massive, much more massive than our sun, 10 times, 20 times, 30 times as massive, looking at how they explode. Because these are real big stars. They make real big explosions. And these stars don't live a very long life either. You know, where our sun will live, maybe 10 billion years, these stars might live tens of millions of years or less. So the question is, how do you get this star that's burning bright, that's super huge? How do you make that explode, basically? This thing that's super energetic, super huge, super happy for most of its life, but burns out real quick and dies. How does that explode? And people can observe it. We can observe what's going on the outside. We can see that these do explode. But trying to figure out what's going on inside is a little bit tougher because there's all this stuff around it blocking our view.
So the reason you make simulations is so that you can control all the physical parameters and then see what the exterior of the star looks like and compare that to observations. So how do your simulations compare to real observations of dying stars?
So for the class of supernova I was looking at, we know a few things about these stars. They make very big explosions, highly energetic, and they tend to make lots of heavy elements during that explosion. We also know some things about the amount of gamma rays that are produced in these explosions, and along with some things, we have some guesses about the amount of neutrinos that are coming out as well. And so these are all things that we can kind of try to use to try to figure out if our simulations match up with the observations. The simulations I did, basically what we found is that the energies did match up very well with what is observed. I put a little asterisk there, though, because the tricky part about simulations is you can tweak the parameters and run more and more simulations until you kind of get what you want. And it's hard to say are you actually finding something that's actually physical, or are you just, tuning your answer here? But yeah, as far as if we look at energies, if we look at nucleosynthetic signatures, so looking at the elements that come out of this, my simulations seem to match those pretty well, or as well as you could for the resolutions and things that I was looking at.
This was all work that you did for your PhD. How has that experience transferred to working in data science? Do you end up using a lot of the same skills that you use to model exploding stars?
Yeah, actually, for sure. And I get this a lot when I tell people, "Oh yeah, I have a PhD in astronomy. Now I work in tech," and people are just like, they just can't even make that connection. But to me, my day is pretty similar. The skills I'm using are pretty similar to what I was doing in grad school. Basically, I mean, we don't use the domain knowledge at all. You don't have to know about stars to do what I do today. I do more research on the labor market and how people get jobs and things like that. So it's a whole different sort of domain that I have to know about. But the tools we're using are very similar. We're using large computers. We're looking at giant data sets and analyzing those in very similar ways to analyzing the data I was analyzing before. We're using a lot of my job is just figuring out how to set up good experiments and how to, figure out how to interpret data correctly. Also how to do good statistical analysis and know that, the answers you come up with are actually statistically meaningful. All of these things are things I learned while I was in school being an astronomer, in addition to learning things about project management, doing presentations, and learning to communicate with other people and work with other people. Really, the vast majority of my skills have transferred over directly. It's just, instead of blowing up stars, now I'm looking at job markets. Or in my former job, I was looking at education and looking at higher ed. So you can change the topics on these things. It's really the skill set behind them that matters. And, really being a scientist is the most important, I think, of all of those.
Yeah, I tell people the exact same thing and often get a similar, somewhat confused reaction about, I used to look at, big data sets of thousands of observations of exploding stars. Now I look at big data sets of thousands of observations of what people are watching on TV. And, you search replace exploding star for, Westworld, and basically it's the same code, the same analysis, and the same skill set.
And do you miss astronomy at all?
I get asked that question a lot too. And my answer has still always been kind of no. The one thing I miss is teaching. That's one thing I don't get to do as much of in my job. And I've really enjoyed that in academia. That was kind of one of the reasons I went sort of the grad school route, as I was thinking I wanted to teach at a university level. And I did teach through a lot of grad school, and now I don't get to do that. So I do miss that piece. But as far as the work, I find it every bit as fulfilling, really more fulfilling in a lot of ways, because I get to see a lot more impact in my results. They're interesting to a whole lot more people. A whole lot more people understand them even. And the nature of the work itself, I enjoy a lot more just because it's a lot more collaborative. And that was something in academia I kind of felt very isolated, and you're kind of, told that you want to become your own scientist and work on your own thing that you can own and say, this is me and this is what I've done. Whereas it's the exact opposite in industry. It's very collaborative. So while I miss the teaching aspect, I think about it in every other way. I'm enjoying what I'm doing a whole lot better.
Well, I agree. I do miss teaching as well, Chris, but at least we still get to chat about astronomy and sciencey type topics, whether it's on three-body problems or astronomy on tap or the science of movies. I know things that all three of us are very interested in and are still active in. So, I still feel a little connected through that way. Plus, I still get to, like I said, see people post about their papers and various news reports and tweets about cool astronomy results. So thanks for joining us, Chris. Always fun to talk to you. Cheers. Have a good night.
Cheers.
Cheers. It's a lot of fun. Thanks.